Alright, hi there, my name is Artem and today will be the fourth JustChess development session. So on the previous stream we ended up implementing a basic chessboard. Let me just show you the... So on the previous stream we ended up implementing a basic chessboard which didn't connect to the backend and sent any events to it. And I will remind that our backend is written in the Go programming language and frontend is written in JavaScript. To communicate them, we will need to have similar types in the so-called transport layer types in both. Initially, I was planning to use protobuf on this stream to write event types for backend and frontend. But as I looked into it, I quickly realized that it is too complex and heavy and also requires runtime dependency. And I hate runtime dependencies. As you can see, currently we have only three of them as I remember. So we have SQL driver, we have WebSocket implementation, we have crypto stuff. So uh, those two I don't count because they are my own modules. We also have indirect one, but it is not used anywhere in the code base. So my problem with protobuf is, first of all, the generated code. Even for small messages, it's inconvenient because it's not even a Go style code, because we have some interfaces and some OOP stuff like for simple structures. So I don't like this code. The second is it requires a runtime dependency. So with that being said, I don't want to use protobuf or other complex stuff to simply generate language bindings for event types. So as I'm using Go for backend and I have already written the types I need, so basically we are talking about the event types. So basically we have enum, event kind, and also we have the simple structure, which we need to convert to the JavaScript. So the thing that might change a lot is this kind enum, because I might add new event kinds and remove them. So I don't want to manually keep the event and backend types up to date. So I want to use some type of code generator to do so for me. So I was looking for a Go type generator for JavaScript, or Go type generator to JavaScript. But for my basically, how to say, to my surprise, I wasn't able to find one. So we have Go types generator for TypeScript, but we don't have one to JavaScript. And it's basically really pity because TypeScript files are completely useless for my personal use case. So as we are using JavaScript and there are no available, or at least I couldn't find one available type generator from Go to JavaScript, so let's actually build one. And I have already created a new repository called GTT, which stands for Go Types Transpiler. So let's actually build one. And to build one, I have actually looked into the TypeScript implementations, Go Transpiler to TypeScript, and I saw that they're using something called go/ast package. So so we need package go dev go/ast. So AST, or abstract source tree, is basically a representation of the Go source code, which we will use to generate type bindings. So Go is really good language to do this type of stuff. I honestly think that it is the best language out there because it has really reasonable amount of language structures or expressions. So We have only structures, we have interfaces, we have constants, variables, and that's basically it. It doesn't have much of the complex like classes that are nested or that inherit each other. So basically, I think it will be easy to implement a really simple type generator. So, and the standard library provides those really convenient packages such as go/ast and go/parser. And yeah, we will use them definitely in our case. So let's actually try to. All right, so let's close unnecessary stuff and let's actually jump into the code editor. Okay, I misclicked. There we go. So by the way, I'm sorry for the possible background noises as I'm sitting with the opened windows and balcony and my neighborhood is kind of noisy, but it is so hot out there so I can't just close any windows. So yeah. So we created an empty Go module. So let's actually think what we are going to implement. So we are going to implement a transpiler, and if we will Google the transpiler, we will see that it generally consists of three main parts. So let me see the image. So yeah, we have AST of the original language, we have the intermediate model, and we have the AST of the target language. So I will do something similar to that architecture, but with some, let's say, nuances. So basically, first of all, we need to actually parse our Go source code file. So let's do that using the go/parser package. So go/parser package is also in the standard library, and it has a function called parse file, which reads file input from a string, slice of bytes or io.reader, and produces an ast.file representing the complete abstract, so syntax tree of the file. So basically, it is what we need, exactly what we need. So let's actually use it. I will say that I will make an internal folder where we will store all our internal packages, and let's actually make a package called walker. So what it will do, it will walk the source code file and transform it to the intermediate model. So it basically will cover these two parts of the architecture. And I actually have a lot of uh, information on the internet. I have read a lot of information on the internet that for the transpilers and compilers, the best way to implement them is something called test-driven development. So what it is basically you've written the tests firstly, and then you implement the minimal code that covers all tests that you have, all test cases that you have. And it allows to firstly think before implementing something, and after all, in Transpiler, it is the most important stuff. So we need to decide which parts of the Go language will we cover in the Transpiler. So for my use case, and I want to keep it simple on the stream, I want to cover the constant types and basic structures with JSON tags. So we will completely ignore any functions. We will also completely ignore any, I would say, variables, but maybe we will not ignore variables. Let's see how it goes. So, okay, with that being said, let's create types which, so let's create an actual intermediate model. So the abstract source tree operates on abstract nodes, which is a pointer, and it has a position and the position of the first character and the position of the last character. And that's basically not convenient to work with. So we will create our own type node, which will be, I would say, even an interface, because we will have different type of nodes. And each node will have a method called kind, which returns something called not kind. So not kind will be an enum. So what kind of nodes do we have? We will have a generic node which will represent, so gen node represents the type or the type declaration actually. We will have a value node. So the value node will represent the constant of or variable declaration, because actually in the Go programming language, let me show you. So in the Go programming language, we have this type generic declaration, which doesn't distinguish between import, constant, type, or variable declaration, basically. Yeah, so it has this token field which actually say what are we declaring. So both constant and variable will have values. So the value node will represent those two type of declarations. And we will also have something like struct node, which will declare a structure. And actually here we will also have the type or structure field declaration. So as for now, I think we will have three type of nodes. I think it's reasonable. So let's actually declare them. So the generic declaration will have the name and the type. So when we are declaring the type, we are saying the type name, and here we specify the type. Here is the syntax. We might also specify the interface or structure in the type, but it will be actually the structure node will represent the structure, and interfaces we will do them later. So let's actually add a to-do, or let's actually add a node. Interfaces are not supported. So the value node will have the actual value, which we'll store in the string, and it also will have a name, and it also will have a type. So let's actually say that it embed the node gen and also have a value. So the structure node, so node struct, sorry, will also embed the generic node, and it will have something called fields, which will be a slice of node generic. So seems reasonable. Let me actually set up the code editor size. Okay, this looks fine. Oh, what I did. Okay, this looks fine. Okay, now I think you will be able to see the whole text editor. So yeah, let's actually move the declaration of the nodes to some other file called node.go. And as we apply in the test-driven development, let's make a file called walkers_test, and let's put some tests here. So I suppose we will need to declare some file called test.go. Yeah, let's actually make it _test. And here we will have let's actually say that we will be declaring some type footh int, and let's declare some other types. So those will be the basic types. So Go has really few basic types. So we have the integer ones, so those will be converted into the JavaScript number. This will be converted to JavaScript boolean. This will be string. This will be number, and those two will be not implemented because not supported by our Transpiler, because they are actually not supported by the JSON encoder either. So encoding JSON complex type support Golang. Yeah, so AG complex numbers, channels, and functions have no default representation and result in semantic error. So we will basically say that complex 64 and complex 128 types are not supported. Okay, so we will have this file with some basic types. So let's actually write a code that parses the file. So we will have a type walker structure. It will have something called ast.fileset. Oh my god, if I can type. No, not fileset. How is it called? How is it called? Field. No, that's not it. There was some type which represented the abstract source tree actually. Maybe it is called a file. Yeah, it's called a file. Yeah, file node represents a Go source file. So we will have this file, ast.file. And we also need something called, so the parse file returns the, okay, file set. So the file set represents a set of source files. Methods of file sets are synchronized. Multiple coroutines may invoke them concurrently. Yeah, we also will need that. So let's call it fset token.fileset. And let's make a function called initWalker, which might return walker and error. And here we will pass the path to the source code. So here we will actually try to, so the fset will be token.new file set. And here we will have something called file error parser.parse file. So the parse file expects the file set, the name of the file, source, or which might be nil, and the mode. The mode is basically a flex. So let's actually provide the necessary parameters. And the mode, I suppose we should also, yeah, so we have all errors, declaration errors, imports only, package close only, parse comments, skip object resolution. Yeah, I think we will parse comments so that we will be able to preserve the documentation, actually. It's kind of cool. So if error is not equal to nil, we will return that error. And otherwise, let's actually simply return like that. So we need to actually specify the path to the source code. So let's actually, okay, so here we will now declare the walker, and the path will be according, so when we are running test, we locate it in the package in which we running the test. So we will need to go to the test folder and we grab the test underscore test.go file. Give me 1 second. All right. And so here we will have a method called walk. And walk will actually traverse the source code file, the AST of the named source code file, and convert it into the internal representation used by Transpiler. So it will basically return a slice of our nodes. Basically that's it. Yeah. So for our test file we should return something called something like we have 3 nodes, so we will have node generic. All of them will have the name and the type. This will be foo. Alright. So how do we compare the nodes? So we need to make a function called rNodes_equal. Yeah, let's actually change the naming a bit. I think it's kind of confused and not following the Go conventions. So we should prefix the enum with the node. And here we should basically do something like that. So for the value nodes, we will actually want to compare the values also. Alright, so we will compare them using this function called rNodes equal. Yeah, seems fine. And yeah. So we will walk the source code file, we will expect this intermediate representation, and we will compare them. So if length of the got not equal to length of the expected, we will immediately fail. And then we will compare the individual nodes. Okay, seems reasonable. So for now, this will obviously fail, but let's actually implement the code so that it covers this specific test case. And later on, we will add more details to this test case and implement just enough code so that it covers it. And basically, that's called a test-driven development. Okay, so how do we walk the abstract source code tree? So first of all, we already have this abstract source tree file, and we have the file set. So the AST package provides this file. No, this is token package. We need AST package, and this file structure have a field called decals. So we see that it is a top level declarations or nil. That's basically our case. So if the file decals, so if the file doesn't have, if the source code file doesn't have any top level declarations, turn basically nil. Let's actually make it like shortcut. Source code file doesn't have any top level declarations. And if it does have some declarations, we will walk each of them. So for declaration in range declarations, so we have this ast.decal type. So decal is actually an interface which represents an arbitrary declaration nodes. And so to see what exactly is this declaration, I suppose we need to cast it to the actual type, which implements this interface. So we have, we have decal statement, and I suppose it implements the declaration interface. I suppose. And we have the generic declarations with const type or variable token. Alright, so I think we should use it. So we should switch between the actual declaration type. And here we will have something called, so yeah, it might be, alright, we have a lot of, so it might be bad declaration, function declaration, so we will use generic declaration. So let's see, let's actually, here we will print skipping unsupported declaration. And I think it have a position. So position of the first character. So let's actually print that position. So we will support the generic declaration. We also will support the structure declaration. Struct type. Oh, so basically structure declaration will belong to the generic declaration because it belongs to the type declaration. Okay, makes sense. So as for now, I suppose we will only support the generic declaration. And also the AST package provides this really convenient print function for the debugging purposes. So let's actually call that and see the which fields does this object have. So let us see. We have some error because yeah, we need to return the array. So let's actually return the empty array for now. So alright, so let's actually debug this stuff. Okay, so we have successfully read the source code file, and it has these declarations. So we have exactly three declarations, and yeah, all of them has the generic declaration type. So they have the documentation. All right, they have token position, they have token type, and the specifications. Okay, so I suppose the specifications. So in Go we can have the block of types. So this is actually similar to something like type, and here we will specify those types. So I suppose here the specifications will have three distinct types, and for this syntax each of them will have a single type in their specification. So let's actually try that and make something called, I don't know, let's make it QWE. And we have no errors, so yeah. Let's actually see how it looks in the debugger. Alright, no, this is not it. So let's debug this. So in this case, our file will have 4 declarations, but the fourth one will actually contain 3 specifications. Alright, so yeah, we need to look at the specifications. Yeah, that makes sense. So each specification has its own documentation. It also has the name. I suppose, yeah, it is the name of the type. And it has the type field which contains the information about the actual type. Yeah, it's actually pretty reasonable. The API is good, I think. So let's actually, yeah, let's go ahead and parse them. Why not? But I also wonder, so as I want to preserve the documentation, I think we should keep track of both the declaration documentation and the specification documentation. In case so basically this is the declaration documentation. So let's see, declaration. Okay, let's see how does it look. So we have the declaration. The declaration has its own documentation, which is the declaration doc, and the specific first type will also have its own documentation, I suppose. Yeah. So we need to actually keep track of both of them, because so this documentation will override the declaration documentation, but for those one, yeah, we will have the okay. This is not as important for this specific point, but we will definitely need to implement that later on, so I want to keep track of everything from the very beginning. So okay, we have the generic declaration, and how does it looks in the actual terminal? Let's actually see. All right, so the debug console looks something like that. Okay, we have the generic declaration. Yeah, those are basically those fields that we see in the debugger. Okay. All right. Seems reasonable. So here we will actually need to, let's actually make a function called something like parse generic declaration. So it will return an array of nodes, I suppose. And so here we will call this walker.parse generic declaration, and here we will have the actual declaration. All right. So this generic declaration has documentation, and yeah, it has token. So here we will need to switch between the declaration token, and in case of token type, I suppose, case token const, case token var, and here we will skip fmt printf walker skipping unsupported declaration at, let's actually print the name. In this specific case we have the declaration name, so let's actually oh, we don't have the declaration name, I suppose. Okay. Okay, so let's print the position. I wonder how does it looks if we, so for example, if we will have something like import sync. Okay, so let's actually import. Okay, how do we import? Let me see. Link import package. Without. Okay, I think we should do something like sync. Okay, the auto formatter. Let me actually do something like. So let's write this in the GNU Nano, so it doesn't. So the Go FMT doesn't format and remove the unused package. All right, so let's see what do we got in this specific case. Okay. So let's actually make a breakpoint somewhere here and debug. So parse the generic declaration. Alright, so this token has type import. Okay. So let's see what do we got in the console. We have skipping unsupported declaration 15. Okay, 15. I wonder why it is 15. The column. Okay. Okay, so I suppose this is the. So internally it looks kind of like this, I suppose. So the 15 is the column of the. No, the beginning of the import statement. So yeah, the position looks like that. So let's actually. Okay, let's don't save this file. All right, it's okay. Okay, so yeah. Yeah, okay, so maybe we can do something like. Maybe this will look better. And so let's try that out. Yeah, that looks kind of better because we have the more information than just the position. Okay, so let's keep that and continue parsing our declaration. So if we find a type declaration, so here we will call something like parse. So let's store the nodes here. So we'll have nodes, and here will be so the internal node buffer accumulated during walk. Okay. So here we will have parse const, so parse type. Here we will have parse const and parse type, parse var, sorry. I suppose we will actually, they are kind of similar, so I think we should keep them in a single function called parse value node. Here we will have parse actual generic node, and here we will have parse struct node. Okay, seems reasonable. So here what do we have? JD dot. Okay, so here we will okay, so this will be actually Walker parse. Okay, so this will be a parse declaration block. Okay, and here for I specification in range jd.specs. Here we will do something like that. So this will be parse. Okay, specification dot. So let's actually print the specification. I wonder how it looks. All right, it looks okay. And so this will be skipped, I suppose. Okay. So this will be type specification. Okay. Type specification, type specification. And do we have a struct specification? Struct. Okay, type spec. Ident, parent, selector, statement on a or any other XXS. Okay, so we have this type specification, and the type field defines whether it is a structure declaration or the basic type declaration. So I suppose the ident will be the generic type declaration. It is all right, seems like everything is fine. I wonder why it displays sign into chat, but I will do it later. Okay. So yeah, here we should look at the specific type. So we'll switch between as type, and in case this is a st struct type, impossible type switch, variable of interface type spec cannot have dynamic. All right, no. We should look at the okay type spec. Okay, so we should convert them to this type spec, and okay, so we need to. So if the declaration block, so let's actually name it block specs block. So if we encounter, so if the block has a type of type, then we will cast each specification to the type specification. Type specification. So this will be type specification, okay. And if it is not okay, then we will obviously print unsupported the actual specification. And cannot use variable of type specification as declaration. Let's actually make it something like x_any, so that we will be able to print everything in our console. So yeah, so this is type specification, and this type specification we need to look at its type. Okay, yeah. So we need to switch between ts.type, and in case it is an ast.identifier, this will be basically, so this will be a basic type, and in case it is a struct type, so the default will be, so we will have array, channel, function, interface, and map. Okay. Skip this stuff. And this will be Volker print unsupported x. This will be type. Okay. So here we will call Volker.parse generic node. This will be parse structure node. Okay, and those two will be parse value node. Okay, makes sense. Makes perfect sense. So the generic node will be, yeah, we need to pass the generic node. It will be ast.identifier. This will be what? Oh my god. So this will be structure type, ast struct type. and this will be specification. So so this will be this will be unimplemented, this will also be unimplemented. So let's focus on the generic node. So generic nodes are something like this and this. They are the simplest ones. So we need to, so the ident has a name and it has object obj. I wonder what is obj. So let's actually print them. Fset, and let's print this identifier. So yeah. Okay. Why am I always going back to the terminal? I guess it's muscle memory. Okay. So what do we got in our console? We got something like, okay, so we have the generic declaration. It is unsupported, it is import. So we have identifier with the name integer. Okay. Identifier with the name integer. So identifier is the information about type. So let's actually specify that it is information type ident. So the type ident will have the name. So this will be type name. So walker.nodes append walker.nodes the generic node. Oh my god, I'm sorry for that background noises, guys. It's unbelievable, but yeah, my neighborhood is something else actually. There is nothing I can do with it, unfortunately, because it's too hot. Okay, so the gen node, should be simple gen, and the name will be, we actually need to, yeah, I'm sorry for that noises. Okay, so then the name should be, I think we don't even need to have this function. Okay, I have also so now I understand that we also need to keep the documentation here. So yeah, we need to keep the documentation. Okay. And here we will actually, so this has the documentation.txt. Okay, so we need to have a function called parse doc parse documentation should return a string. So it will accept the specification documentation. So here we will have spec. No, we have block documentation. Is it? No, it's field. So this will be block doc. It is ast.comment group. What is actually comment group? So a comment group represents a sequence of comments with no other tokens and no empty lines between. So it is basically a slice of comments, and a comment is, it has text excluding /n for those style comments. Okay. The text field contains the comment text without carriage returns that may have been present in the source. Because a comment send position is computed using len text, the position reported by comment end doesn't match the true source and position for comments. Oh my god. Okay, so I think we should use the text method. Okay, let's call it block comment group. So this will be block comment group, and this will be the declaration comment group, and they both have time comment group. So this stuff will work something like that. So if returns the decal cj if it is declared, and block cj otherwise. So basically the decal cj has the higher priority and overrides the block comment group. Okay. So if block cg, if decal cg is not equal to nil, then we will return decal cg dot text. Otherwise, else, if block cg is not equal to nil, we will return block comment group dot text, and if they are both nil, we will return an empty string. So the parse doc will be, it shouldn't be the method of the walker, so the parse doc, this should be a block cg, and this should be a x.ts.doc. Okay. So let's see what do we got in the debugger. Okay, so this is our identifier, the first one, which is the foo. Okay, so this is our, so this is that type. Oh my god, English. Okay, so our nodes now should contain the okay, so basic types with /n and foo int. I think it makes perfect sense. So we have parsed the first type. Congratulations. So let's go ahead and parse the so let's see what do we got. So here we should have 6 declarations, 6 nodes. Each of them will have the type of gen and basically okay, so let's run this test. So the expected is fooint bar string. Oh, okay, yeah, because we need to. Yeah, I mean, probably should. Okay, so let's make nodes. And return those nodes. Here we will do something like nodes, append nodes, and this one. So this should also return a node slice. So here nodes will be with the length of block specs. And here we will nodes, append nodes, and this one. So this will return a single node. And this also will return a single node. So this will be okay. Here we will return nodes. And here we will return okay. So we probably should have something like error here. So unsupported node errors.new. Okay. Parse type declaration. Something like that should be fine. But here we will return oh, since it is an interface, it might be simply a nil and we don't need this one. So it should be simply a nil. So parse type decal returns a nil node if the declaration is unsupported. Okay. And here basically so here basically if it is nil then we print that it is unsupported, and if it's not nil then we append that node. This should work just fine. Okay, so let's see what do we got. Okay, so this test case is passing. So from this representation and from the go/ast package, we have made those generic nodes, and it is much more convenient to work with these types than with those pointers. I think you will agree with that. So we are basically doing pretty good. Now we should continue and parse the structures. So yeah, let's go to implement parse struct node function. So for the structure nodes, it will probably need to okay, so we need to return the structure node here. Oh, simply struct, sorry. So here we will return a struct. So the structure has the name, which will be something, so we don't have the name here. And I suppose it's because we should, we need to have the name string. So the name will be test name.name. Okay, so this will be structure type name. We also need to have the type. So for the type, I think we will declare some constant called struct type. This will be basically something like struct. So the type will be struct type. And we will also, what do you mean? Unknown field name. Not sure about that. Maybe I should. Oh, so I suppose we need to use something like that. I suppose. Okay, yeah, we need to use something like that. Okay. And we also need to parse the fields. So the fields will be something like gen of the length st.fields.list, and the fields will be so for and field in range st fields.list. field.comment, field.names. Okay, so here we should basically parse the basic declarations. Oh no, it has tags. Okay, so the structure can have the JSON tags. So the JSON tags are pretty common feature in the Go programming language. It allows to modify the default encoding/JSON implementation. So we can specify the custom. Let me see the documentation. Yeah, so we have 1, 2, 3, and maybe 4. We have four common types of JSON tags. The first one simply sets the name of the field to the custom, which will appear in the JSON. The second one, omit empty, we will not use it because it's useless for transpiling purposes. Next one is the minus sign, which completely ignores the field, and basically that's it. So we should definitely parse them. So let's begin with, okay, so let's make a function called not that. So the tags, let me see the documentation for the tags. Tag is basic lead. Okay, the basic lead is the basic literal. Okay, so it has the kind, it has the value. So I suppose we need to look at the value. So I wonder how does it look when we have, so the value 0, so the value might be an array, I suppose. Okay, let's actually print the st for that. st.print. So yeah, let's actually see. So we have this structure with those fields. Let's actually see. And we are seeing something. Yes, so this is our struct type. It has a field list. Okay. And okay, so yeah, here we have the JSON. So we need to manually parse them. I see. Okay. So here we will have something like parse structs fields. So if field. So first of all, let's skip the unexported fields, because unexported fields will not be used in the JSON encoding, and those will not be used in the frontend. So if field.names I wonder how to check whether it is exported or not. So names ident name names. Okay, so we have this is exported method. So if it is not exported, then we will skip this field completely. Next one is we need to parse the JSON tag. So if field.tag is not equal to nil, if it's not equal to nil, then we should split the tag. So let's actually make something like JSON tag prefix. Okay, yeah, this is this prefix. So if and f tag value contains has prefix JSON tag prefix. Yeah. Other tags are ignored. So if it is not nil and it has a JSON tag prefix, then we will strip that strings trim prefix. So let's actually see tag and JSON tag prefix. We also will trim the suffix, which is the end of the tag. JSON tag suffix. And here we will trim that suffix. So here we will have a value of the tag, the value of the tag. So we need to split this by a comma. Okay, so if there is a minus sign, then the field will be completely ignored. So completely ignore the fields. So how do we, I suppose, is skipped. By default is false. And here we set is skipped to true. And if is skipped, then we will break. And if let's actually make it here. So if it is skipped, then we will continue to the next field in the field list. And here we will have, if it is omit empty, then we will basically do nothing. Ignore the field tag is ignored. Okay, so let's do something like that. Omit empty tag, since it is useless for transpiling. So it basically only affects the runtime JSON encoding. So the string is a special tag, converts the field type, forces the field type to be a string. So the field type will be by default it will be type dot by default it will be type ident. Okay, that makes sense. And after that, we will need to append the parsed field to the fields slice. And that's basically it, I think. So this will be skipped since it is unexported. This will be this x field name will be set to x smaller letter. This will be skipped because of the JSON tag, and this will be the default as in source code. Okay, so we are expecting that one, and we got the basic types. Oh, I forgot to put the documentation in here, so I also basically forgot to put the documentation. So the block doc will be st dot. Where is the documentation? It's kinda interesting. So this will be okay. So here we will have the name, the ts.doc, and the block documentation also. Block CJ. So here we will have block CJ and struct CJ, st comment group, and yeah. Okay, the import declaration is gone. I will remove it. It is not used. So let's add the documentation. So this should be Okay, I think it's pretty nice. Let's actually trim. Okay, let's keep it like this and run the test one more time. So we have a syntax error, unexpected new line, which is okay. So here we need to parse documentation of the block CJ and struct CJ. Let's name it decal CJ. So we have basic types, specification documentation, declaration documentation, and so we are missing the W type. Oh, no. We are completely missing the structure declaration because we need to append them. Okay, that looks better, but we have this stuff. Okay, we probably will need to append the breakpoints. Okay, we need to actually set the tag after we trim in the prefix and suffix. My bad. Okay, and it works perfectly fine. So now we have intermediate representation of the generic declarations and the structures, which is pretty nice. So the only thing left is to actually write the transpiler itself, which will operate on these intermediate nodes. And but I don't want the string to be too large, so I probably will extract the transpiler logic to the next stream. For today we did pretty good, so let's actually commit our changes. And let's write a detailed comment. So structure walks the AST of the named source code file and converts it to the convenient intermediate representation used by Transpiler. The Transpiler itself isn't implemented yet. So yeah, I think for today it will be enough. I will add the README file and push the changes to the repository. By the way, it can be found on my GitHub page. It's called JTT. So thank you everyone who will watch the stream, and basically have a good day, and yeah, see you on the next stream. Probably will be tomorrow or on Saturday. We'll see. Okay, bye.